In problem number 3, this is where it actually starts to get a little bit tricky. So let's go ahead, let's look at the problem, see what we have, and see what we need to know. So our known, given a hydroxide concentration of 3.2, so it's different from our last problems. So we have 3.2 times 10 to the negative 12. That's our hydroxide concentration. What is our unknown? So we don't know our pH. Now, this is where it gets a little bit tricky. A lot of you are going to want to try to put this into that equation. But if you look at it, it's got the hydronium concentration. But we were given the hydroxide concentration. So we cannot quite use that just yet. Okay? So what we're going to do is instead, we're going to take this value and we're going to use this equation. So if I use this equation, I'll be able to find my hydronium concentration. So let's go ahead, let's do that. 1 times 10 to the negative 14 is equal to, we don't know the hydronium concentration, so I'm just going to leave a placeholder, times 3.2 times 10 to the negative 12. So at this point, I look at this and I know I need to get this by itself. So in order to do that, I need to do the inverse order of operations and divide both sides by 3.2 times 10 to the negative 12. Now, you need to be careful to put your parentheses, because if you don't, you're actually telling your calculator to divide by this and then multiply by that. But you want it to divide by that whole value instead. So at this time, I'll put that in my calculator. (3.2) times 10 to the negative 12. And I get 0.03, or sorry, 0.003 as my H3O concentration. But have I actually answered my problem? No. So let me go ahead and erase some of this. So we now know our hydronium concentration. So we can actually now use that to plug into our equation to find our pH. So negative log of 0.003125, that's all those numbers in our calculator. And when we do that, we get 2.5. So it'll be 2.5 as our pH. And then we are done. So our pH is 2.5. So that is our answer, so we are good.